Let's learn Singleton design pattern in Java. I have created one class Singleton. In Singleton design pattern, whoever creates object of a particular class, how many times ever they create, they should get the single instance. They should not get different instances. Now let's try to create an object of Singleton class. One more time I'll create. Now let's try to print these object references to check whether they both are same objects or different objects. Let's run the main method. Here we see that object references are not same, which means that these two objects are different, they are not same. But Singleton design pattern says that the two objects should be pointing to a same reference. Now how do we do that? When we are calling this new Singleton, it is calling the default constructor of the Singleton class, and that is how the object is being created. We can check that by adding a default constructor. Now let's try to rerun. You see that this default constructor has been called twice to create these two objects, and both of those objects are different. In order to make this Singleton create only once, we will make this constructor as a private so that other classes cannot create object using new Singleton. Then how we can create an object of the Singleton class in not using new Singleton? For that we will be creating a method. We'll name the method as a getInstance. It should return a Singleton type, so return type is Singleton. But here I want to get the object, means I need to call this method. If we have to call any method without creating an object, we have to make use of static method. Then we can call using the class name. Here the class name is Singleton, and we'll call this getInstance method. Same goes here. We'll call that method and try to get the object. Now we'll try to implement this method. This method has to provide a Singleton type object. We can return a new Singleton like this. What happens here is that when you call first time, it creates a new object and returns. When you call second time also, it creates a new object. So this new Singleton should not be returned. We need to make sure that object is created only once, and from second time onwards we need to give the first time created instance. So in order to store the instance when it is created for the first time, we will be using one variable of type Singleton. We'll name that as an instance. Initially it will be null. When first time this method is being called, we'll check if that variable, if we want to access this instance variable here, this method is a static, so we need to make this variable also static. First we'll check if the instance is null. If it is null, we'll create an object and we'll store that within that reference variable itself. and simply return this instance. So if it is null, it will try to create a new one and store within that, and finally it returns that. Now let's try to run this code. Now you can see that constructor is called only once, even if you are creating object, getting the object twice. And you see that these references are also pointing to same address, which means that these both objects are same, they are pointing to the same reference. So this is singleton design pattern, but this works in only single threaded environment. How we can verify is that, let's delete all this code. I'm trying to create multiple threads. We can use executor service for that. I'm adding 3 threads to the pool. For these 3 threads, I'm submitting 3 tasks. The first task is just call that get instance method. Now let's try to run the code and see what happens here. You see that the default constructor is called twice, which means that there are 2 different objects that have been created in multi-threaded environment. In this scenario, how do we protect our class so that only a single instance is returned? We can make this get instance method as a thread safe by adding synchronized keyword. Now what happens here is that at any point of the time, only a single thread gets a chance to create new object. Let's try to run now. You see that only one time the object is created, which is fine, which is desired. But making this entire method synchronized will affect the performance, as we need to control only the object creation. So we'll remove the synchronized keyword from the method. So this line itself is we want to control. So we will put that in a synchronized block. I'll remove it from here and I will add it here. For synchronized, there needs to be a lock. A lock is this particular class itself. So what is the meaning of this is, we are submitting 3 tasks for 3 threads. So 3 threads will enter into this method at the same time, because we have removed synchronized. They enter into this method at the same time and they read this condition, whether they will check instance is null or not. These 3 threads will check, but only one thread will be having an access to create an instance at a given point of time. So for example, all the 3 threads read instance is null, so all the 3 threads wants to create an object, but at any point of time only one thread will be allowed into this particular block because this is synchronized. So for example, first thread came and it created an instance. 2, 3 also will be waiting for creation because they already read the instance variable as null. They will not be reading it again. Once the thread 1 creates a new object, right? Thread 2 and thread 3 also tries to create object. That is the reason we were getting a constructor called twice. In order to prevent that, the waiting threads which already read instance, they can read it again. So I'm adding one more if block here. Even after waiting, if the still instance is null, then you can go and create an object and put that to instance. This instance variable is being updated in a multi-threaded environment. So when multiple threads are trying to access any variable and try to write, right, we need to make that variable as a volatile so that all the threads will be able to read the latest value in that one without any delay. Now let's try to save and run the code. So the constructor is called only once and our goal is achieved. So this is the singleton class which works even in multi-threaded environment.